Hi everyone, my name is Anvita Bansal and we are back with another lecture based on recursion and backtracking topic. So the question for today is permutations of a string. So let's move to a sheet and see which question there is. Let me check if you guys are able to see my screen. Yes. Okay, have a look. So we are going to discuss permutation of a given string. Meanwhile, let me also, I think that's okay. Fine, starting off with this question, so let's have a look. So what you are given in this question is you are given a string S. Your task is to print all unique permutations of a given string in lexicographically sorted order. In short, in increasing order as if they are the words of a dictionary. Fine. Okay. So how do you find all permutations of a particular string? So let's have a look and understand. First of all, the very basic thing is how many such permutations are possible. Let's say I have A, B, C. So if I try in layman terms, how it will be? It permutations means all possible ways in which I can form this string from all these three characters. That means displacing their original positions. So what are the possibilities? The possibilities are you find all the permutations and what are the number of ways. It's as similar as if you try to understand it in mathematical way. It's like you are given a set, or you're given some container with, let's say, three different characters, right? And you want to form a string out of these three different characters. So what are the how many such strings can you find? So it is as same as from a slot of n, like you, or you can say from a bundle of n characters you're selecting one. So what are the number of ways? When you select one thing, let's say you're selecting one item from n items, so you can choose any one item in how many ways? N c 1, right? Then now since you have chosen one character already, you are left with two different characters. Now what will be the number of ways in which you can choose these two characters? That is, from the remaining n minus 1, select one, right? And now you are left with only one, so that is n minus 2 cu1. So you keep on doing this until you are left with no items in that box, right? So what are these? What is this? Anything nc1 is what? N only, right? You know this, n factorial divided by n minus 1 factorial divided by 1 factorial. What does it give you? N into n minus 1 factorial will be cancelled and you will finally be left with n multiplied by n minus 1 multiplied by n minus 2 and so on. So n into n minus 1 into n minus 2, so on, let's say up to 1, right? Until you are left with one character. That is nothing but n factorial. So how many, if you have these characters with you, different characters, how many permutations of this string are possible? So it is equivalent to n factorial. That is where n is the length of this string, which is 3. So 3 factorial is what? 6, right? So at least this is for understanding that you know how many such permutations are possible. Now in what ways can we find these permutations? One is this naive way only. We have already learned in recursion how using permutation we can find permutation using recursion, right, of any particular given string. That can be done, very naive approach. But how do we solve this problem? The brute force approach is you go and find all the substrings, then not substrings, you find all the combination possible. But using recursion, let's how are we going to deal this problem? So to be more precise, it is more of a backtracking. Very minor difference in both, not actually not even difference. So basically we will be using backtracking for this problem. Now how? So let's say we are given one string ABC, okay? Now what I want, in what ways can I find different permutations? The possibility is right now is combined with BC. What if I combine C and then B? This is one way. Okay, then you made a change with the last two positions. Why not make change with the first two positions? Okay, C, A, B. But this is so random. This is so random. Just trying to create the permutations. Okay, then let's change the last indexes left. extreme right and extreme left. So that will become CBA. But you think this is so randomly I'm doing. Just doing a hit and trial in all the positions. So with C, I can change these positions. Then if I change these positions, I'll get this. So why not change my first position? Till now in any of these permutations, I do not have B as my first character. So let's put B here and put A, then C. Other possibilities is that you put B, you remain let B be here only and change with the positions of last two characters. So this will become CA. Now I can still have one more permutation, that is keeping A at its own position and play with the other two characters and their position. So it will become ABC. So you know what did we do here? We were trying to keep one position constant, one position was maintained, right? One position was maintained and we were trying to swap, not even swap, we were trying to play with the rest of the characters, right? And when we were trying to do the same for the other characters, we were doing actually the same thing. For example, let's say if your string was like this, ABCD, so how would you be doing? Let's say you are keeping A constant, B constant and playing with the positions of last two characters, so it will become DC. If you keep A and B a constant, again you already have CD, so no more possibilities are left. So let's do one thing. Let's now, you were keeping AB constant, let us keep A at its own position and play with BDC. Okay, so if you want to play with BDC's position, you will be doing either you keep D constant, right? So if you keep D constant, this will become C, this will become D, this will become B. So these two are basically swapped here. If again I want to make D constant, there are no more possibilities. Next thing I can do is you keep C constant and swap them. D, B, C is one possibilities. What is the other case possible? So right now you were keeping B at its own position. Then no, you were keeping D at its own position. By keeping B at its own position, you already formed these two permutations. Then you kept D at its own position and you then what did we do? By keeping D constant, we got CB, right? And keeping A constant at each of these cases. Now what else can we do? Let's do one thing. Let's keep C at its own position and A will still remain at its own position. We can play with these two characters, so it will become BDC. So have we formed this? Yeah, we have already formed. So no more permutations with these three are left. So like this, basically it will keep going on and on if I do not make this so much random. And if you want to actually understand what is happening, so it is typically happening like this: A, B, C, D, right? I am trying to swap A with A. Now what I am doing, see, and try to understand this thing. At every position, I am trying to give chance to each character to be there and then check what kind of a string I'm getting. So I am trying to play with all the characters that I have at each position. So each position has how many options? Let's say I talk about 0th index, 1 index, 2nd index and 3rd index. So 0th index has how many possibilities? It can have A, it can have B, it can have C, it can have D. So for each possibility, I have to check for the remaining ones and they will have further these many options. Each of them will be having 4 options. As bigger the string, as many options will be there. And recursion will be able to solve it easily. How easily? It's just that we will be asking smaller subproblem to solve what is the string that I might get if there was total one character, only one string. If there are total two characters, so what kind of how many permutations can I get? I can get two permutations, AB and BA. So I am going to make use of these smaller answers to combine with bigger ones and know how many total permutations are possible, right? So in order to achieve this, achieve this thing that I can keep a track of if I have tried the combination with each character at 0th index. So for that, what can I do? Swap A with A. Let's try it on smaller strings so that you will understand better. Now we are moving towards the actual approach for this problem. Till what I did till now, it was to help you get understanding or to get to that intuition behind this problem. So I hope you have understood the intuition so far that we have discussed. I also want to know if you guys are able to see my screen. Give me a second. Yeah, so I hope you understood the intuition so far. Okay, and this in this case, let's move to the actual recursion tree that I'm going to draw here. Okay, let's wait. Okay, so it is A, B, C, let's say. So what are the possibilities? The first possibility will come like this, that you want to swap A with A, keeping A at its own position. So like this means I'm swapping A with A. So if I swap A with A, I will get A, B, C, right? Let me write the possibilities first. Okay. So you have A, B, C with you, A, B, and C, correct? Now we are keeping track of, I am swapping A with A. What will I get? So this is what I am trying to do. I'm trying to put all the characters at zeroth index. This level of tree is trying all the possibilities for zeroth index. So zeroth index, first possibility is keeping A at that position, which is already there. Then I will try with the remaining characters after A. So why not swap A with B for this answer and swap A with C. So when I swap A with A, the string that I'm going to get will be what? A, B, C. When I swap A with B, I am going to get string B, A, C. And when I swap A with C, the string that I'm going to get will be C, B, A. Is that right? Fine. Now, next level of tree will be for checking all the possibilities at first index. This level was for checking zeroth index. Now this level, the further level, will be checking all the possibilities of first index. So when I have this as my string, I will again check for the options of swapping B with B first of all. Then the next option I will have to swap B with C, and there are no more characters after B. So the string that I will get will be, from this combination I will get A, B, C. From this combination I will get A, C, B. Why? Because I'm swapping B with C. And why did I not swap with A? Because for A, I have already taken the case when I was swapping A with A and A with B in this case, right? So you are always progressing towards the next characters and not bothered about the previous ones, because previous ones are already taken care of. That is why we are moving towards down in our recursion tree. You getting this point? Okay. So coming on ACP. Are there any more possibilities? So we were checking. So what we were checking to swap the character at the first index. So what characters were after one index? There was only one such character. So we tried out all the possibilities for first index. So that what I got finally is ABC and ACB. Any more possibilities are there? No, no more possibilities. Let's try for other strings also. So here at this level, for all the strings, I'm checking for characters, possibilities of characters at first index. What is this happening? Fine. Okay, coming on to this one. So I have B. A will be swapped with A. A will be swapped with A. So I am going to get BAC. And in the next one, what I'm going to get is swapping A with C. So swapping A with C will give me BCA, right? So let me write it. So I swap A with C. Fine. So it will give me, in this one again, swap B with A, B with B first, and then swap B with A. So let's see what strings are we going to get. So when I swap A with C, I am going to get BCA. For this case, I am swapping B with B, so it will be CBA. And for this case, I am swapping B with A, so it will be CAB, right? So what strings I got? ABC, ACB, BAC, BCA, CBA, and CAB. Do you see any repetitive string here? Any repetitive permutation did you find? No. So we will also ensure that we do not find the string that we have already evaluated. So finally, now when I come below, this was for first index. Now I will check for the second index, right? So for second index, what options you have? You can swap C with C. Do you have any other option? No, there are no more characters to swap with, so there are no possibilities. Same goes for these. You can swap the last character with itself. So same thing will go in every string, and then you will have no more characters to swap with, so you will finally get this string. So what is your base case condition? When you iterate over the entire length of the string, that is, let's say we are iterating over with some idx index, right? When it becomes equal to the length of your string, that is, it reaches nth index, that means you must have found a string with total of n characters, right? There must be 3. If this was for 3, I must have got 3 characters, so I will add it to my answer list or any array list which I want to return, also checking if it does not already exist. If it does not exist in that particular string, add it. Fine. So this is going to be your base case condition. Now wait, where is the backtracking being used? So this tree, I just showed you the possibilities in this tree, but is recursion going to do it like this? Is it going to go and check it first? It will go all to the depth of one particular branch, then it will backtrack and form all these answers. So how recursion is going to take place for this question is, see what was happening. You made a call, initially your string, this was your string, your idx was 0, right? So for index 0, what you did, you were swapping all the characters that were present from idx till n minus 1th index, correct? So right now your idx is 0, so you start swapping with 0th index, and when you swapped with 0th index, you got some character got swapped and you got this string. Now in that string, then you are passing this after swapping. You are basically, so this is a for loop in which you are doing what? You are swapping the characters of what? The character at which index, at ith index, right? Which will be this. You will be swapping it with idx index, right? So that's what you're doing. And this is your for loop, let's say, which is taking index I from idx to n minus 1. So what is I at this right now? It is 0 and idx is also 0. So you swap a with a, that is the string that you get. So this string will call recursion. So let's say we have this function which is calling recursion on the string now after swapping. So after swapping, I still have ABC, so recursion will be called. Now your index will be what? Your index will be equal to what? idx plus 1, correct? Why am I doing so? See, initially you were doing for 0th index. Now when you are making a recursion call to next one, you passing this string, but you are making your index increased by 1. The reason is, now you want to check all the possibilities for the next index, that what all characters I can place at that index and check. So right now this was, so when you made a call to next recursion call, that was for index 1. You started with 0, now it is for index 1. So it will also do again one same thing. Your I will be called from current index, that will be from first index. It will swap b with b, and then I will commit this recursion call. So this function call will be made to abc again, and now your index will be at which position? Last index. So again a recursion call will be made to this function with abc, and right now your index is at this position, so I will be called from idx to n minus 1. Now your iteration will be done only for one time, that is for the last character, which will be swapped, and finally no more will be left. Now wait, now your function call will be returned back to that function which made a call to it. So you will come at the next line of this recursion call, right? So at next line, when you want to backtrack, you will swap again at what you swapped previously before entering into this recursion call. So if you actually swapped c with c, you will again make it back to the original string that was before calling this recursion, because you want to explore more options, but there are no more. So again next backtracking call will be made. So now you are at this call. For this call, you already made a call when you were swapping this with this. Now your I will be incremented. Your I will come at this position, that is your second index. Now second index, your I is 2, but your idx is still 1. So 2th character will be swapped with 1th character, and this is a string that you're going to get, and you will make a function call for this particular string with idx plus 1. That means for the last character, and recursion call will be made where b will be swapped, and then you backtrack further. When your I will see that you have already reached n minus 1th index, okay, then there will be no more calls to make you. So that's how you are backtracking. So in this, first let me now write the code. Basically this is a pseudo code. This is entirely what you are doing. Let me write a clean code. then you will understand completely the things that I'm trying to tell you. After writing the code, we might come back and see how the function calls are taking place using that function. So all in all, we are basically doing this only. We are actually calling a loop of some, let's say iterator is I, that goes from idx to n minus 1th index, right? And then you're swapping it. This is how you're swapping it, making a next recursive call, which is further making recursion calls. And when you're backtracking, you make sure that the, like for example, when you're backtracking from here to here, from here to here, what you are doing, let's say you are backtracking from BCA, right? So when you're backtracking coming back to BAC, you want to make sure that your string is back in BAC form, so that let's say if it had D after it, now it wants to swap C with D, so it needs to make sure that string is back to its original form from where it made a call to BCA, right? You getting this point? Or if it wants to swap B, D, C, A like this, so it has to retain its original form. That's why we are swapping it again during backtracking process, correct? So let me see if you guys have any. Okay, so if you have any doubts, you can write in the chat. See, index plus 1 is equal to length of string shouldn't be the base case. The reason is when you are back, let me show you. Wait. What is happening when you are making a next recursion call and swapping C with C? So the string that you will get will be ABC only. From here, now you will another call will be made. Currently your index is already at second index. Your I is already at 2 at this position. But as per the function loop, you will make a call to another function which will be calling for ABC, and will be at third index. Now when that particular index is equal to n, which is 3 here, that is when you know that you must have already gotten a string of length 3, because if length is equal to 3, indexes will go from 0 to 2, right? So if your index I becomes equal to 3, idx becomes 3, that means 3 characters have already been taken care of already. So when index becomes out of bounds, exactly, to be very precise, that is when you know that's the base case, that you have already collected the answer that you wanted to. Now you just store it somewhere and make sure that you have not found the same permutation before and add it to your answer. So is your doubt clear of base case condition? Okay, fine. Let me just write a code here for you so that you can understand. Let me take another function which is handling this recursion. Okay, fine. So if I write another function, public void, let it be permute. Okay, string s I am passing, and there is one list of strings. See, what you finally want to return is an array list of strings which is containing all the permutations of these characters. Fine. So that is the list of string I am creating as answer, in which I will be storing. And since I am using one index to make sure which characters from index to n minus 1th index should be taken into consideration for the swapping, so for that I have taken this index. So I will check if this index with which I am keeping a track, it reaches what s dot length. If it reaches s dot length, then you have to do a few things. The few things are, first of all, you will create, also before you do that, since this is a string, and I will take another character array, char arr, another character array, you can write like this, or so this character array will have the characters of the string that will be formed as part of our permuted one. Fine. That permutation of string will be stored as characters into this array. So from this array I will store that string into this string answer string str. String str will be equal to new string and this arr. Fine. and then I will check this final list of answer, if it does not contain dot contains this str, then you will add it to your answer. Ans dot add str. Fine. And then you return. That's what you are doing. Okay, this is your base case condition altogether. Then you are using a for loop for int. I starts from idx. When your I is 0, so you're swapping a with a, and then you are swapping a 0 with 1, 0th character with second character. When your index is 1, then you are starting from 1th position to n minus 1th position. So whatever your index is, you basically start swapping from there, and your I goes till last character, that is n minus 1th position, and you can write n and then I plus plus, right? That's what you're doing. So I starts from idx. Then you are swapping what you're swapping this in. Let me pass this idx and I, and which character I'm using. Let me write it arr. I will write the swap function. Then you are making a call to this function, recursion function, which is asking a string, will be taking answer, will be taking arr, and will be taking, now your idx will be what? So what was previous index? It was, if it was 0, the next index that you are checking to find all the permutations will be 1. So at each level of tree you are increasing your index, right? So it will become idx plus 1. Okay, so that's what we are doing. And finally, when you are backtracking, you make sure that your string is back into its original form from where that recursion call was made. So you again do the swapping with idx I, and arr is the array of characters that I'm passing, right? So this is your function. Now let me write the swap function. So public void swap int a, int b, and character array c, character array arr. So char temp will be equal to your arr of a, then arr of a will be equal to arr of b, and then arr of b will be equal to temp. Fine, that's your swap function. And now finally I am going to create a list of string ans that I'm going to pass it new array list. Fine. Then I will have this character array new char, or I can write it character array. Basically I have converted this string into my character array, so I don't know, I think there is no need of passing this s also. I can simply pass this character array. So there was no need actually. Let it be, I will change it. Fine. So it will become your s dot to, how do you change it to character array? Char array, right? So this is the character array, I'm changing it. And what else do we need? Character array int 0. Let's make a call. Let's make a call to this. So permute s, capital S, then you are passing this answer array list, then you are passing this arr, and then you are passing this 0. Fine. Also, when you have final answer array list, you will sort it because you want to return lexicographically sorted array. Let's check. You will see if there is any. Comma, let's try again. And I equal to idx Why is it not able to find? Variable n, okay, is less than s dot length. Stack Overflow, let me check where idx plus 1. Expected, let's submit it. Fine. So this is how we are doing. Now let's reiterate with this. Let me just take this one and we will reiterate once again. I'm sure that you must have understood by now. Space between. Thank you so much for the comments. Yes, I teach every day. I come live with this GFG channel every day. I'm still live, right? Okay. So let's come back to this problem. Meanwhile, if you have any doubts, you can ask me. I'll just check. Guys, if you have any doubts, please let me know. I hope I'm still live. I can see, right? Yeah, okay. Fine. Coming back to it. What I was discussing with you was this problem, right? Now, so there is other way also, but I will not come back to this way. I will take that in another other problem. So soaping is just one way of behind this intuition. The entire intuition was that I want to check all the possibilities at each position, right? So for that I chose a soap method. Other thing that I can do was I can take a string, an empty string, and then how many characters I have, I try to put each character at each position and try all the permutations. That same thing can be done. Instead of soaping, it's like forming an altogether a new string. So let's come back to this dry run once again for the last time using this string s list answer. Okay, so let me just write it. I have fine. I think it will not come entirely. Okay, but we can understand from this. So what is happening, everyone? Look at this. You have this return for, let me take this. Okay, right. So let's have a look what is happening here. So when we are making a call for zeroth index, we start with zeroth index. Let's have a look. One more dry run over this. Okay, we start with zeroth index, right? Initially, what do you have? You are passing zero index, right? You are passing in your permute, you are passing that string, and I am writing only this index here. You have zeroth index initially. So you check. You come into this loop, you take I starting from 0 and it goes till what? It will go till second index, that is 0 to n minus 1. So when you're I 0, you're swapping it. You're swapping idx with I. Idx is what? See, here I will be writing idx. You can understand it in this way. Don't get confused with I and idx. Idx is the index which is telling me that which index am I keeping a track for right now at that particular level of tree, in terms of tree if I want to understand, and I is iterating from idx to n minus 1. So when my idx was 0, it is 0, my I is also 0, so I'm swapping a with a and making a call. So call is being made to permute of with index what, idx plus 1. Idx was 0, it a permute call is made to idx I plus 1. So this permutation will further go ahead, and in this case your index is what, 1 is your index. So what will happen here, your I was 0, a was swapped with a, now you made a call for what, idx 1. Now your b is there, your idx is 1, and it goes, your I is also 1, so you will permute b with b, so and make a call to next permutation, which will be for which index, idx plus 1, that will be for 2. So for 2 your index is 2, your I is 2, and now you permute what, second index with second index, so you get abc finally and make a call for permute of 3, idx plus 1. When you make a call for permute of 3, here idx will say that I am equal to s dot length, so I will store whatever string I have found so far. So the string that I have found so far will be part of my ARR, right? So the string that I will be finding now, it will be added to my ARR, this ARR character array. So character array will have ABC as of now, so this will be added to my final answer. Okay, then I come back. When I come back, I will see any more calls can be made, no. So it will backtrack from here. So when it backtracks, it goes to the next line of its next line after permute, which is swapping. So it will retain its original position and come back to the permutation call which was made just before this. So are any more possibilities there? I start, so you will check in loop, so your loop is running, right? So it was at 1, it can go till 2. So now your next call will be made for when I am swapping b with c. So when I swap b with c, I am making a call to permute of next index, that is 3. But now I am, this is the call that is happening, this is the call that is taking place, you're getting it? So acb was called, so on and so forth. I hope you got the entire gist and problem. You can do it yourself if you have understood the logic easily. So this entire recursion is very easy, just you need to understand what is happening all behind in using the recursion tree, right? So finally when you hit the base case condition, you will have all the strings that must have been formed using different permutations. So that's all about this problem. Coming on its time complexity, so you know that we are just what we are doing, we are using a loop here, right? Since we are using a loop here, and for each loop basically we are doing this task of finding permutations. So permutations can be found, this permutation can be found in n factorial ways that we have already seen, and how many times it is being called. In the worst case, it is being called for n times because we are using a loop. So n into n factorial is your time complexity, right? So this is the approach in which we are not using any extra space, right? We have only created this character array which we have used from string, we converted that string to character array, and we are storing our answers in this character array only, which we are adding to final array list of answer, right? So I think you have understood this problem. If you have any doubts, you can ask me. So let me give you my LinkedIn ID. So this question is a very good question, which is quite frequently asked, and which any interviewer if is asking you this question and you are able to crack this, okay, with its logic is important. See, the code is very easy. How much code did we write? Lines of code, if you see, is hardly this. The entire logic is behind these 3 lines. Where are those? Yeah, these 3 lines typically. But the logic is very important to understand. So that is the important part behind this. So backtracking will be very clear if you understand this problem. Second thing that I was discussing is, so we use this method of swapping. The swapping thing we are only doing because we want to try out all the possibilities at any particular index. Another thing can be that I told you, you can take a new string, empty string, and start from its 0th index till nth index, n minus 1th index. Try out all the possibilities. I can fill up any character, any, this is 0, this is 1, this is 0 position, 1 position, 2 position. So 0 has how many possibilities? I can fill it with A. So if I fill it with A, I will get a string A and rest empty. So rest empty, now this will have again 3 options. So fill it with B. Now I have third one and I can fill it with again 3 options. Right now I filled with ABC. So when I filled with ABC, I backtrack, and now I have which option for the last character? No other option. So I backtrack. So A, after A, I can do what? I can use C. So it will form AC, and then I will have a last option ACB. So an empty string has been filled up like this, and then you backtrack again, you backtrack here. So from here, when you had A, you gave it C, you have given it B. Is there any possibility left? No. You just change the 0th character. You start with B. So for B will have 2 more options for the second character, that is A and C. Okay. When you fill it with A, you get BA. Now you have only one option, so you fill it with BAC. BAC. Now you backtrack, you have which option for B? You have C, so you fill it with BC. Now you only have one option to fill the last character, which is BCA. You backtrack. Now you come at this position where you fill your 0th character, 0th index. So you fill it with C. C has how many options after it? It can come along with A, it can come along with B. If it comes along with A, it will become CA. So CA will have only one option left, that is CAB. So like this you can do it. Okay. See, so this is the best efficient approach that we can use, the one that we have coded with. So this is the efficient approach of solving this problem using backtracking method. The second approach, this approach that I was telling you, this particular approach can also be used. The question will be solved, but the one that we use, this first one, is efficient than the second one in terms of space. Not in terms of time complexity, but in terms of space, because we are forming a new string. So we have to keep a track, we have to maintain some space for this string every time. So this string is extra space that we are taking, and with swapping we are just reducing that extra space, because we are making change in the current string that we have. But for this particular method, you will have to pass a new string. Your string will not be constant, so the changing factor will be your index, IDX, and the string that you're working on. So these two will be the variables or states that will be changing in the second method. So that will affect your space complexity, nothing else. So any more doubts, if you have, you can ask me. And yes, the question is formed and asked for the cases where, for this question, you do not have to worry about duplicates, but there are questions where you might be given, what if the string has duplicates like this. So that can be solved in the same way, just that when you are trying to swap, you just keep a check if the previous character, right? First of all, you will sort that string and you will check if your previous character is not equal to the current character. Only swap if it is not equal. So that small change I would suggest you to try. If you try it, if you understood this approach, this is the hint that I'm giving you. If you have duplicates, you can try it with duplicates. If you have any doubts, you can always connect with me and ask me. But yeah, for this problem, this is the efficient approach. Okay, so if you have no doubts, I will wrap it up. Fine, so shall I wrap it up, everyone? Let me have a look at your comments. Thanks for attending the lecture, guys, and I come live every day. I'll just tell you the flow of questions that we are taking up. So this is your SD sheet. I started with arrays. You can check in GFG SD sheet, your practice channel. There is this GFG practice channel. In playlist, you will find SD sheet. So in SD sheet, if you want to start practicing today, you can start practicing all of these questions, and you will find the good, almost all the questions. Few very easy questions I have not taken video over there in that playlist. Searching and sorting is done, hashing, matrix, strings is done. Now we are on recursion and backtracking. So I've already taken up these 3 questions. Today we took this also. Tomorrow I will be taking n queens. Fine. So yeah, tomorrow I will be taking n queen. So whenever you want to check, first of all, you can always check on YouTube GFG playlist. Let me just open that up. SD sheet. Wait. So this is the playlist. In this link, you can find the upcoming lectures also. Like if you check, you will, when you scroll to the bottommost, let me show you. See. So if you see, so these are your, this is the current lecture, these are your upcoming lectures. Tomorrow I'll be taking n queen solve Sudoku, and then next day rat in a maze. So these are very, very, very good questions. A lot of times these are asked in interviews. So I think that's all for today, everyone. Wrapping it up. See you all tomorrow in the next lecture.